Connecting and calculating three-phase auto transformer banks with single-phase manufactured auto transformers. All right. Well, let's get going and see how we can then connect individual single-phase auto transformers into a three-phase bank. A single-phase manufactured auto transformer will typically have a diagram like this. It's going to have a single winding and a whole bunch of taps, and it's going to show the core. Now, if we want to use a manufactured auto transformer in a Y auto transformer bank, then we need three of them. If we're going to calculate, or if we're going to connect an open delta transformer bank, we would only need two. Now, keep in mind that the total bank kVA would be calculated the same as isolation type transformer calculations that we have done with three-phase up to this point. Well, let's look at this first example here. We have three individual single-phase manufactured auto transformers, and they're rated 5 kVA each. The first thing I'm going to do is calculate the total kVA of the bank. Well, there's 1, 2, 3, and we're going from 208 to 480, and it's a auto transformer Y. That means we have a total of 15 kVA. Now, if I have 15 kVA, that also means that I should be able to work out the total line current that we could potentially supply this 480 volt load. So 15,000 divided by 480 times root 3, and that gives us a current value of 18.04 amps. Now remember, the 15 kVA is also present on the primary side, and that would mean that the primary rated current for this installation would be 15,000 divided by 208 times root 3. Kind of hard to get the glare off there, but you believe me, equals 41.63 amps. Now, more importantly, we want to know, how is the connection going to be made? Well, let's take a look at the top diagram here. We have a common point, a 120 and a 277. So the 277, remember, this is all in phase locations. So this is in a phase, phase, and phase. So although the line voltage does not align at all with the ratings on the transformer, that doesn't matter because the transformer itself is connected into the phase. First step, we should connect all of the common points together because this is going to form our star point of our Y transformer. Now, the X and the H, I've just put X and H instead of the voltage because it's smaller. X is for the 120 and H is for the 277. So X 120, that means, well, phase voltage for a 208 volt system is 120 volts. So that would then mean that we must be connecting the supply side, or primary, to the X terminals. So we have a connection like this. 1, 2, and 3. Now the 480 volt side has a phase voltage. If you were to apply root 3, divide by root 3, you would end up with 277 volts. And so that must be the voltage of the individual phase for our 480 volt system. So I'm going to use red for this, and we will see that from the H terminals, 1, 2, 3. Now this type of system will be very specific by the manufacturer if they require a neutral connection on the primary side or the secondary side, typically the star point will be grounded. And so that would be an additional connection to the center portion here. Now, what if we wanted actual three-phase four-wire? Well, no problem. All we would then have to do is run a separate wire from here, and this would now be our neutral. So there's all sorts of fantastic ways that we can utilize this. And really, the calculation is no different from the standard isolation three-phase. The main difference would be the particular size of the actual transformer itself. A 5 kVA auto transformer is substantially smaller than a 5 kVA isolation transformer. Let's look at another example. This time we've got three 5 kVA auto transformers and they're rated 240, 277. And we've got a 416 and a 480 volt voltage here. The 416 is something you'd more see for European spec equipment that comes from overseas. And so we need to adjust the voltage for that. So we already know that the phase voltage for a 480 volt line voltage system is 277. So I'm just going to do a slash 277 volt. And over here, the 416 volt, if we apply root 3, so divide by root 3 to get the phase voltage for a 416 volt three-phase system, we would come out to 240. So in this situation, a little bit different. We're stepping down and only stepping down a very small amount. What is the total kVA that we have available? Well, it continues to be 15 kVA. And that would also be 15 kVA on the primary. For the connections, well, we still have a Y, so that means we need a common point. So there's our star point. And now we need to look at what winding is going to connect to what side of the circuit. So this being the lower voltage, we're going to be connecting to the X terminals. So here's my X terminal, 1, 2, 3. The primary side is going to have the H terminals connecting back to the 480 because remember, from here to here is 277 volts. So we come out of the H, 1, 2, and 3. So the Y-connected auto transformer, again, will have the star point grounded, and it's up to the manufacturer, depending on what sort of connection we're doing. It might be grounded through the neutral on the primary or maybe a neutral on the secondary, but we will have a ground connection to that star point. All right, well, let's take a look at the more common auto transformer bank that we're going to run into because this more common application is far cheaper. Anytime you can do a connection with two of a object instead of three, you reduce your cost by a third. So we've got two single-phase 5 kVA auto transformers. They're rated 480 600 volt. And in this situation, it's pretty straightforward because all we're dealing with is the line voltage values. First thing we need to know is that the two transformers are connected together. And so we connect them together. I'm just choosing to use the C or common terminal on my two transformers here. We have X and H on both transformers. The X connects to the 480 volt supply. The H connects to the 600 volt supply. So first connection is going to go to the 480 from the common terminal. And then my X is going to go to my 480 volt and the X on the other side. The high side of this installation will connect to the exact same point. We didn't even have to come from here. It could have come from there. It doesn't matter. And off of the H terminals, we then progress back to our 600 volt load. Now, what would be the total kVA that we could supply here? Well, it is an open delta. And so open delta still means that we have those percentages that would be applied. We are going to have a total value that is going to be 86.6% of the two transformers that are present. So times 10 kVA. That, of course, gives us 8.66 kVA total load that this particular installation could provide. And of course, that would be the same on the primary and the secondary. Let's look at one more open delta. This time we're going from a 600 volt system to a 240 volt three-phase system. Again, only line voltages are being used, which then means that we have the same voltage ratings on our auto transformer as we do on our sources, well, our source and our load. So I've just put in X and H there. So common terminals would tie together. We would have one of these going off to the 600 volt side and one going off to the 240 volt side. From the X terminals, I'm going to be going back to the 240. So the 240, one of the X terminals here and the other X terminal on this side. And then I've got my H terminals both connecting back to the 600 volt side. And again, we know that the total kVA is going to be 86.6% of the original two transformers that are rated 5 each, which then gives us 8.66 kVA total.